In our last lesson, we learned how to work with decibels. Today we want to go a little farther and see how decibels work when we start combining sounds together. Alright, so remember your formula. You find intensity, you plug it in, and you find your intensity level in bells. You multiply by 10 and you get your decibels. So today it says, during a pep rally, which has been a while since we had one, a student in the gym was screaming at the top of their lungs. They were producing a sound with a power of 0.009 watts. How loud was the sound from a spot near the center of the gym, which is 20 meters away? So as we said yesterday, we do power divided by 4 pi r squared. You want to use the power of 0.009. You want to use the radius as 20, and don't forget to square it. Okay, when you get your intensity, you're going to take that and put it into our formula for intensity. You're then going to find the B value, and I believe you're going to get 6.25 bells, which is going to work out to be 62.5 decibels. All right, so check through, work through the math, and hopefully you get the same answer that I did. That's no different than what we did yesterday. So what is it we want to do next? We want to look at what happens if there's not one source of sound, but multiple sources of sound. So how loud would 2 students be? Well, we would think that if one student was 62.5, the 2 students would be 125 decibels. But we clearly know that this can't possibly be right because we're starting to hit the level of a rock concert with just 2 screaming people. All right, so something is not right in terms of the way that our brain thinks we should deal with decibels. So what we really do is we don't double the intensity level. We go back to our calculation of intensity. Let me fix that for you. And when you get your answer for intensity, you double it. So whatever you get for one student, you double there. Then when you plug it into your formula here, because of the way that logs work, you are not going to get double your answer. You're only going to get a small change in terms of the actual level of the sound caused by the second student. If we want to do 10 students, again, we do the intensity of 1, but this time we multiply by 10. We take the intensity, plug it in, and you'll see that with 10 students, we bring it up to around 72.5 decibels. One student was 62.5 decibels. So it took 9 extra students just to be able to raise it from this level to this level. So it definitely is not working the way that we would think. Logarithms make everything different, and the math is not the way you'd expect. Try it with 100 students, 1,000 students, and then 1,001 students. And what you're going to see is with 1,000 students, we're going to have an intensity level around 92.5 decibels. And adding another student is just going to change a small amount in terms of the sound level inside that auditorium. So the first student brought us from 0 decibels to around 62 decibels. Each new student we add causes a much smaller change than the previous student. All right, so it's kind of weird how this works out. Okay, so this next one is also kind of weird. We'd like to see how many extra decibels does a person speaking in a normal conversation voice add to the total sound when a lawnmower is running. So we have to flip back to our decibel chart. We have to find the lawnmower, which is 90. Normal speech is 60. We want to keep those two numbers in mind. And we want to add them together. So we get 60 decibels, 90 decibels, and we want to add them. And we would like to just add the two numbers, but that's clearly wrong. Somebody talking next to a lawnmower does not create a sound of 150 decibels. That's louder than a jet aircraft on takeoff. Okay, so how do we do this? Well, it turns out you have to do this formula twice. Once for the person speaking, so we plug in a 6. We would get rid of the log. We cross multiply. And we get the intensity of the person speaking. We do the exact same process for the lawnmower. This time we would get 1,000,000,000. We then solve it for I. And now instead of adding the two decibels together, you add the two intensities together. You would get a total intensity of 0.001001. And you can see that the person talking adds almost nothing to the sound level created by the lawnmower. To find the actual decibels, we just take this number, plug it back into our decibel formula, and you're going to find that the decibels is almost the same as it was without the person talking. It's just going to be a fraction above 90 decibels. So give it a try and see what you get. Okay, I'd like you to do one more at the same way we just did that one. This time I'd like you to do a lawnmower and a vacuum cleaner. Okay, so you're doing a 80 and a 90. And again, don't just add them together, but work backwards. Find your two intensities. Add your two intensities together, plug them back in, and find the decibels of the combination of vacuum cleaner plus lawnmower. I know this math is a little tricky, but if you take it slow and you remember all the things we learned about logarithms, I think you're going to be okay.